Depending on the position of the vertex and the direction of opening of the parabola, we can determine quadratic functions which have two x-intercepts, one x-intercept, or no x-intercepts. So what we're going to do here is we're going to sketch the graph, and then we're going to come up with a possible equation. So for two x-intercepts, there's two possible ways of doing that. It's depending on whether the parabola is facing up or down. Now, if it's facing up, it's got to cross the x-axis. So for example, something like this. Okay, you'll notice the vertex is all the way down here. Okay, so in this case, we could say that A is going to be positive because it's facing up. But the vertex, well, the K part is going to be the most important part because that corresponds to your Y. And so K has to be negative if it is going to be below the x-axis. The other way that this may work is you have the parabola facing down, but in this case the vertex would have to be above the x-axis. So A would be negative, but K in this case would have to be positive because the vertex is all the way up here. Okay, so let's just start off with this one right here where we have a parabola facing upwards, something like that. Now, using the general equation, we're going to replace the A with something positive. It doesn't matter what it is. It could be 1, 2, 3, 50, 100,000, doesn't matter. But in this case, I'm just going to keep it simple. Let's make it 2. It just has to be positive. And in brackets, we've got x minus something or other. Well, it doesn't really matter for the h, because that's just going to affect where it sits along the x-axis. So I'm just going to say it is 3. Keep in mind, watch your signs. Now with K, that's the one that really matters because it's going to bring everything up and down. Okay, so since it's down here like this, it better be below 0. So I'm just going to say here something like -3. Next up, we have to find one x-intercept. So the only way that would really work, there's a couple of things to keep in mind. It can be up or down, that's not a problem. So for example like this, but the vertex actually has to be right on the x-axis. Okay, so it can be like this as well. Okay, so A can be either positive or negative, but the key here is the K, because that's your Y of your vertex. Okay, the Y of the vertex, well, if it's right on the x-axis, the Y is going to be 0. Alright, so Y, let's just we'll make this one negative this time around. So A, we'll just say that is -4. And in brackets, well, it doesn't really matter for the H as well. You could have x plus 3 squared, and then K is going to be 0, so it's going to be plus 0. Or if you rewrite this out a little bit better, Y is equal to -4 x plus 3 squared. Next up, we have a situation where we don't want any x-intercepts at all. So here's an example. If the equation was positive, you'll notice it doesn't touch the x-axis at all. Okay, so that's if it was positive. If we had something where the parabola is facing downwards, in that case it's going to be below the x-axis, just like so. Okay, so in this case what we can say here, if A is positive, then the K better be positive as well. If the A was negative, then K better be negative as well, just so that there will be no touching of the x-axis. So for example, if we have a positive A, we'll say that would be 7 for A, and it's a positive A. Doesn't really matter for the H. Could be anywhere along that x-axis, so I'll say -6. Okay, so remember, notice how I switched the sign there. Remember, of course, that the general equation is x minus h, that's why. And so since this here is positive, that must mean here that K better be positive as well. So that's good. I'm going to give this a +9, for example. So this would be an equation that would satisfy something like that one. You can always check these in your calculator when you're done as well.